Okay, so I do believe this is the last session of the afternoon, so you guys don't have to suffer too much longer. So with those that have been with us all day in this session, we kind of started off with the kind of foundational data elements that we extract from our Fuser database. And Andrew gave us a couple really good talks about how we turn this Fuser database into a consistent file where essentially each row is a flight. And then we have some 450, data elements or metrics associated with each flight. And then in the previous session, we showed a little bit of what can we actually do with this data, where we kind of walk through some of the benefits of pre-scheduling into the overhead stream. And so to kind of wrap us up here, this last talk will be about the benefits of surface departure metering. But when we talk about the benefits of surface departure metering, we really need to make sure that we're doing no harm to some of the other operational metrics. What do I mean here by some of the operational metrics is more so than anything else, we heard about it this morning at the kind of keynote, is that downstream on-time performance. So the idea here is that gate holding is acceptable by the operators if they can maintain that downstream on-time performance. And so we really focus on that downstream online performance when we try to assess, are we doing any harm to the operations at Charlotte? So to get into this, the ATD-2 phase 1 system got rolled out into Charlotte. And part of kind of both the phase 1 and phase 2 systems that we've been running for the last 2 years essentially has been surface metering. And when we started surface metering, for those that were in some of the earlier sessions, Andrew talked a little bit about how we do the analysis to determine banks, which bank aircraft are in. And so very early on, we kind of understood that Charlotte has this banked structure of traffic such that there's peak periods of demand and then lulls in between those peak periods. And so early on during surface metering, when we were in the kind of initial testing phase, we said, okay, let's try to pick out the busiest bank, which we determined was bank 2. And that locally at Charlotte kind of operates somewhere between maybe 9 to 9:30 to 11 a.m., somewhere in that area. And so we turned surface metering on at Charlotte in bank 2 starting in November 29th. And the data that we'll show on these slides goes all the way through July 31st. So what we see here, and then eventually, after kind of having some initial success during Bank 2 operations, surface metering was expanded to Bank 3 shortly after, somewhere in February 2018, February 19th. And then eventually now, I think that, the benefits of surface metering and kind of that positive impact at Charlotte kind of encouraged surface metering to expand even to additional banks beyond 2 and 3. And now we see surface metering kind of used throughout the day, which we find very encouraging. But to give some kind of high level view, since the start of ATD-2, Bank 2's been metered in 472 distinct days, which is about 77% of our overall traffic during this time period. And Bank 3 was metered in 369, or about 70% of the traffic in between February 2018 to July 2019. So you can see here that Bank 3 was metered slightly less than Bank 2. One of the reasons being is that if you look down here, this shows kind of those average demand levels across the two banks. And what do we see at Charlotte is that Bank 2 has similar number of departures. However, Bank 2 has about 50%, 47% more arrivals than Bank 3. And so that additional kind of arrival demand, especially when you think about that dual use runway that accommodates both arrivals and departures, really drives up the delay and ultimately ends up manifesting in the fact that Bank 2 gets metered more often than Bank 3. So this shows kind of our demand level, so about 77 departures, 77 departures in banks 2 and 3, and roughly 76 arrivals, but only 51 arrivals in bank 3. This tells us about the flow the airport was running in during these kind of metering operations. So you can see the green here represents north flow. So, roughly about 2/3 of the operations have been in north flow during metering, where about 1/3 in south flow. As we had mentioned earlier in the previous session, the north flow operations are much less complex than south flow because the ramp is right next to those departure queues in south flow, and so it really causes a lot of complexities. And so if, the fact that we're in north flow 66% of the times is, I think, makes the life a little bit easier for the controllers and also for the surface system. One of the things we can try to keep track of as well is what were the kind of average number of departures that were part of these surface metering programs. So the blue here, we break it up by flows. So again, here is all flows. This is for north flow. This is for south simultaneous. So in south, we actually have two options. Luckily, they haven't been running in this third option here, south converging, very often, where they essentially have Charlotte has 3 parallel runways and a 4th crossing runway, and south converging is where they leverage that 4th crossing runway, whereas in both north flow and south flow, they just run in the 3 parallel runway operations. They can definitely get more aircraft on the ground and off the ground in kind of those converging operations. However, life is much more complex in those converging operations. So what are we looking at here in this graph? The blue represents the number of departures. The orange represents the number of departures that are what we call subject to metering. What do we mean by subject to metering is that if a departure calls the ramp and says, I'm ready to push back, and while the aircraft calls the ramp and says, I'm ready to push back, metering is effective in that moment in time, we say that aircraft is subject to metering. Of all the aircraft that are subject to metering, not all will be advised to gate hold. For example, I'm an aircraft. I call ready. I say I'm ready to push back right now. Metering's on. I'm subject to metering. However, the ramp traffic console advises the ramp controller to push me right away. So that's an example of an aircraft that would be subject to metering but would not be advised to gate hold because the system's saying you're ready to push right now. And then finally, of these aircraft that are advised to gate hold, some actually do gate hold, and then the ramp controllers always have the discretion to kind of push them off the gate whenever they feel is best, because ultimately we're just trying to provide some type of decision support to them, whereas they're ultimately in control. So that's why you can see here, again, the blue is all departures. The orange are those aircraft that are subject to metering. A subset of those aircraft subject to metering are advised to gate hold. A subset of the aircraft that are advised to gate hold actually hold at the gate. You can see here, south converging operations, the percentage of flights that are subject to metering, advised gate hold, and held at the gate are higher than the other flows. I think that represents some of that kind of complexity of that south converging operations. And ultimately, if we look across our different banks, we see about 26% in bank 2 are subject to metering, 23% advised to gate hold, and 16% were actually held at the gate in bank 2. And then the numbers in parentheses represent those departures for bank 3. So again, bank 2 has more demand, more congestion, and you see it manifest itself in some of these numbers. So there can be a variety of reasons, but one kind of, I would say, prototypical one is that you have a gate conflict. So you're advised to hold on the gate for, say, 5 minutes, and ramp controller sees there's an arrival at the spot that wants that gate. Ramp controller has the discretion to push that departure off the gate to get that arrival in. And the idea would be is that you can still kind of achieve the letter of the law and meet your TMAC compliance if you push that departure off the gate and hold it somewhere in the ramp. So in the TFDM world, where these aircraft are being kind of graded with TMAC compliance, which is the spot compliance, the idea would be that the operators have the freedom, have the discretion to control the gates however they like. They can kind of get those departures off the gate. They can have them sit in the ramp somewhere else and get that arrival in. They're kind of in control of that. The main idea is that they get to the spot at the kind of assigned time, if that makes sense.
So that's the difference between your total departures or everything in that bank. If you added up, subject to metering, advised to hold, actually held, the difference would be the ones that just
Yeah, the difference between the essentially advised to gate hold and actually held, there's a wide variety of reasons why controllers push them, but that essentially the system in a perfect world would have held that aircraft. What exactly is kind of influencing the controllers to get them off the gate, we can always speculate at, but it's ultimately kind of in their own head.
When they push back, are they sending them into the AMA?
So the ideal concept would be, in the absence of any gate conflicts, you hold them at the gate the whole time, engines off, save all the fuel. In the event of, say, a gate conflict, the idea would be that you can push them off the gate, and then if you have the real estate in the ramp, you can hold them, ideally again with engines off somewhere in the ramp, and then have them show up to the spot at the assigned TMAT time. And so in the full concept, we want to hold them at the gate because that's where you get the savings. But the reality of the situation happens, and then the ramp controllers, it's kind of up to them and their discretion of how they want to maneuver when they have these kind of conflicts of interest.
So if they don't have room in the ramp, and ramps get to be congested, aren't they gaming the system, or at least gaming the other airlines?
Yeah, I mean,
it's controlled by American, I get that, but let's say you go to some other airport. I know TFDM has some compliance metrics. I'm not quite sure.
yeah, so essentially, we track the compliance both at the gate and at the spot. And, we don't have any formal mechanisms to enforce compliance. I also believe TFDM does not have any formal mechanisms to enforce compliance, and that's been an issue, right, with some of the operators that they say, look, you're asking us to play this game, and we all play by the rules, but if one bad actor goes and starts kind of not playing by the rules, how are you going to kind of slap them on the wrist, right? And so that's a great question, and one that I don't have answers to, but that essentially, in the ideal world, that everybody can kind of be accountable to everybody else, and they all play the game according to the rules.
I just wanted to add something to that. So I recently spoke to the JFK operations manager, and they do surface metering at JFK, just like TFDM is proposed to be, just like this is. It's a voluntary program. Everybody plays the game. And what they've said is everybody does play the game. JFK is a very complex airport. They've got a bunch of different carriers, international carriers, domestic carriers, and
Yeah, like intent to hold in the AMA, you can essentially tell FAA like, hey, I'm not supposed to be at the team out for 30 minutes. I'm kind of handcuffed here. Can I kind of sit out in the AMA? Yes?
But follow along a little bit with the gentleman's comments about JFK. That is not, it's not only because of the scorecard. The main reason that compliance is what it is we hold a monthly meeting with all the users, and we discuss compliance and non-compliance. That's really what's been the success, I'll say.
Yep.
It's not just the scorecard, because when we didn't hold, there was a period of time when meetings were not held.
Mm-hmm.
That compliance didn't fall.
Yep.
Give people the opportunity, without, let's say, a monthly check, you'll see it start to.
Yep. I think that's a great point, which is, right, as a community, how can we kind of foster this culture of accountability, right? Because we all should be accountable to each other if we all want to play a game and all receive benefits.
Jerry, as part of the Surface CDM platform, everyone was given the option, if you needed a gate, you could designate an area to hold a flight, whether it's in the non-movement or movement area. If I'm not mistaken, if this state is Charlotte at this stage, it's in the non-movement area, there's still a countdown attached to that aircraft while it sits in like in the West Hard stand or something like that. So there's a reminder that, hey, this one's out here, because there's other aircraft that are spares or whatever sitting in that West Hard stand. This one has a countdown to it to let you know, hey, don't forget me.
Yeah.
I'm out here. But you can also, they're so strapped for service in Charlotte, you can say, I need to take my meter delay, like if you're going northbound on Delta Taxiway. They have to cross active runway, but they'll go over there and they'll cue the aircraft. It will sit there and take its time before it takes off. So this gives guidance, it's even an extra guidance to the FAA and to the ramp people. Here's an agreed upon time, so it's harder to game the system. I mean, I think it's a check to keep anybody from gaming the system.
Yep. Thank you very much, Bernie. Great insights. Any other questions before we move forward?
Real quick, when the pilot says I'm ready, can you say, do you tell him at that time exactly how many minutes he's going to hold at the gate?
I think that this is more a question for American because this is their operations, but my perception of what happens is the ramp controller indicates like essentially hold for X minutes for surface metering or something like that, and that they are providing some guidance to the pilots to tell them how long. Go ahead.
So if he says hold for 10 minutes and he holds for 8, because of the 8, what color bucket does he go to?
The red, if he holds it all. If aircraft holds even for 10 seconds, then it will get counted as red, actual held at the gate. Cynthia, did you have something?
I was just going to say, we've been told that the Charlotte ramp controllers tell the pilots expect 10-minute hold. So they're not telling them an explicit time, but just a general.
Yeah. Yes. Great question. So in the kind of ATD-2 phase 1 and phase 2, that we buttoned up the door as if there was nothing else going on, no surface metering, no nothing. So if you're a passenger, you were getting on at the same time and the door was closed at the same time, and then you're sitting there at the gate holding with engines off, receiving the fuel benefits. However, the passenger benefits of essentially, well, if I held this aircraft for 8 minutes, can I keep the door open 4 minutes longer? Can I load a couple additional passengers, a couple additional baggages? So that we are actually pursuing, right? We're in the process of trying to pursue those benefits at Charlotte, but they haven't been something we pursued in the past. But our hope is over the next year that we're going to start getting a lot more data about that, which is if I hold for 6 minutes, how many more passengers, how many more baggage. This though, and it's unfortunate Carol's not in the room because the people and I'm going to mess up her 3 Ps, but the people and the processes and the procedures is that's a much bigger component of these benefits, specifically of keeping the door open and things, than just the fuel savings. And so I think to achieve those kind of final benefits that the SCDM ConOps kind of laid out, it's kind of, we're at the final frontier and we're pursuing those right now, but we haven't done it yet. Yes.
Where would the bucket fit if you found out that you were going to be subject to a gate hold and you just slowed boarding down to a slower pace? Would that still fit into the gate, or to count as this after boarding is completed? And then
Yeah, so all of the benefits we're going to show are going to essentially subtract your actual pushback time from what we say is the pilot ready time. And so if they start delaying the boarding process, the mechanism we have functioning right now to measure gate hold would break down a little bit. But saying that they haven't been doing that as yet, so all these numbers, they're essentially calling as if surface metering is not happening, and then they're being asked to hold at the gate.
You probably delaying boarding only if you're adjusting your EOD.
Yep. And American has, so we're very heavily in talks trying to understand how can we kind of achieve these final benefits there of kind of surface metering. And like I said, I think from the systems perspective, it's like we have all the knobs and whistles you can need, but from the operator's perspective, these kind of keeping that door open an extra 5 minutes is not like so easy that you can just say, okay, keep the door open. Like there's a lot that goes on there behind the scenes. Any other questions? Okay, so these are kind of our departures and our breakdowns of how many departures, how many subject to meter, and how many advised gate holds, how many actually held. This is a monthly breakdown here of which banks were metered. So the vertical axis here is count of departures, and it's colored here by banks. So the red is bank 2. So as we said, we started off with bank 2, and we essentially metered bank 2 only until February. You can see a little bit of, I'm colorblind, I think it's green, that mainly because they test the systems every once in a while and stuff like that. But so you can see though that the red is been the dominant bank that we achieve most of the gate holding. The green here is bank 3, and then what you can see here is starting in November of 2018 for a little bit of time, they started extending to additional banks, but really starting in April of 2019, you can see that kind of that surface metering has been extended to those additional banks. And we find this very encouraging that the system's working properly, that not only do we have the confidence that we can do this, but the actual operators, American, has the confidence that kind of the system works well enough to expand to those additional banks. So that's an encouraging sign. So when we talk about taxi time, so as I said, we'll talk a lot about the benefits where a lot of times on an individual flight by flight level, we will measure the benefits as the difference between when that aircraft actually pushed back and when it was ready to push back. And then we will sum up all those deltas as gate hold. And then we will convert the gate hold into fuel savings. But another way we could do this is we could say, well, if I had a set of departures that were not metered, and I have another set of departures that are metered, and then I try to analyze, the taxi times, what does the before and after look like, and what is the impact of surface metering? And so on the top here, that's what we're showing, which is the red here is our bank 2 departures before surface metering. The horizontal axis here is the excess AMA taxi out time. So, this is, for lack of a better word, this is that kind of departure queue, how long you spend sitting in that departure queue. And the blue here is the set of flights after surface metering. This is for Bank 2 departures in north flow. So as we showed at the very beginning, about 60% of our operations are north flow. So that's what we kind of focus on here to try to understand the impacts here of surface metering. So again, the top is essentially the excess AMA taxi out time and AMA is the airport movement area. And then on the bottom is the excess ramp taxi out time. So this is kind of in the ramp, how much excess taxi time are these aircraft experiencing. What we see here is, well, first of all, it seems like there's little to no impact in the ramp. The blue and red histograms or distributions are essentially on top of each other. You can see that here. It's probably hard to see in the crowd, but we show an average here, which is before metering an average of 1.5 minutes, after metering an average of 1.6 minutes, essentially, the same, 0.1 minutes of difference. However, if you look up here about the excess AMA taxi out time, what you see here is that the percentage of flights that are experiencing excess AMA taxi out time above 10 minutes is higher before metering. So that red line is above the blue line on that right tail. And the percentage of flights that are experiencing these low excess AMA taxi times, less than 10 minutes, is higher after metering. So what have we done here? We've taken this red distribution and we've shaved off the right tail and we've shifted it to the left. And through this process of shaving off the right tail, of reducing the percentage of aircraft that are experiencing these large taxi times, we're able to reduce the average from 7.2 minutes down to 5.5 minutes. So roughly a 1.7 minute difference in AMA excess taxi time from before and after metering. Not only did we reduce the average by 1.7 minutes, but the standard deviation before metering from 6.5 down to 5.1 after metering. So we've reduced the average AMA taxi time, and we've made the amount of time you spend in the AMA more predictable. I think those are both benefits of the surface system that I think we're very encouraged to see. For those that like to see all the fuel numbers, that's what we'll get into now. So we started off by essentially kind of trying to show the high level, this is how many departures are actually surface metered. Then we went into, okay, well, these are the banks that are metered. This is our estimate of how much taxi time we're saving. But let's kind of get to where the rubber meets the road and try to estimate how much fuel we're saving. So when we think about the benefit mechanisms here, we think that there are essentially these three different benefit mechanisms that we are estimating for phase 1 and phase 2 of the ATD-2 concept. The first one is collaborative surface metering. The benefits here are reduced engine runtime, reduced fuel consumption. As we had mentioned maybe in the previous talk, if some of you were there, for these aircraft that have to merge into the overhead stream, if we can schedule their controlled takeoff time while they're still at the gate, then we have an opportunity to gate hold those controlled flights. So that is benefit mechanism 2A, which is that for those controlled flights that are scheduled while still at the gate, we can gate hold those controlled flights if they receive kind of any delay from TBFM. So these first two benefit mechanisms are one for the surface metering, two for the overhead stream insertion, but they're achieved essentially through these tactical gate holds. So we know you're delayed. We don't want to reduce your delay. We just want to shift your delay from the airport movement area to the gate. The last benefit mechanism here is renegotiating for an earlier slot. And so I kind of stepped through the idea here of this benefit mechanism, but the main idea here is you're a controlled flight, you're an APREC, and you have a release time, you have a controlled takeoff time. However, you get out to the surface, you get out to the departure queue potentially a little bit earlier, and what you see is that, well, there's actually an earlier slot in the overhead stream that I can make now that I'm at the departure queue early. So what happens is the in the tower, the FAA TMC uses the IDAC green space, red space to identify and request an earlier slot in the overhead stream. So again, we have a controlled flight, it has a release time, it has a controlled takeoff time. We identify that it can make an earlier time, and we renegotiate for that earlier time. And then finally, that aircraft receives the earlier release time. And the difference between the two release times is actually a reduction in the delay. This is an interesting concept because when we talk about these concepts, we're shifting from spending time in the AMA back to the gate with engines off. This bottom one is not shifting delay. This is actually a reduction in delay. There's an earlier slot, I can take it, I do. So these are our three benefit mechanisms for phase 1 and phase 2 for ATD-2. And so if we were to focus purely on this collaborative surface metering, what type of fuel savings have we achieved throughout the life cycle of the project? Again, these fuel savings are being calculated as the actual off-block time minus the pilot ready time. So that's where this pilot ready time data element becomes very important. We actually know the exact amount of time between when that aircraft pushed back and when it was ready to push back. And what we see here is that we have saved approximately 1.3 million pounds of fuel. That's achieved by holding just 13.8% of departures at the gate with an average gate hold of 5.9 minutes. And that's an average gate hold for those aircraft that are actually held at the gate. So if you're one of these 13.8% of aircraft that are asked to hold at the gate, you're only being asked to hold 5.9 minutes. From that, we are saving 1.35 million pounds of fuel. This fuel savings can be converted into equivalency of CO2, and that we estimate that we've saved 4.1 million pounds of CO2. That CO2 is roughly equivalent to planting 31,000 trees. And one thing that we should kind of reiterate here is these are just the collaborative surface metering benefits. We have distinct and separate benefits from gate holding the overhead stream and from renegotiating for an earlier time in the overhead stream. So if we said, okay, well, what are our benefits from kind of renegotiating the slot in the overhead stream? So if we go back to our benefit mechanisms, what I just showed you is that benefit mechanism 1 here, collaborative surface metering achieved through gate holds. Now next what I'm going to show you is this 2B, which is the renegotiation and what type of benefits we're seeing there. So, yes?
He's asking for an earlier output an annual call.
So it's actually the TMC will request it, and the TMC has the ability to request essentially any time that they want, but that our surface system also generates a time, and so typically what will happen is they will use, and you can see it here. Do you see this this vertical? So this is the center's view. This is the tower. These green spaces on that vertical here, those are the available slots in the overhead stream. Our surface system will schedule that flight where we think it really has the potential to take off. And so what you would see is, oh, my flight's right here next to this green slot. It has the potential to take off earlier than kind of my control time. I can see that because the surface system's telling me he could take off here. The IDAC system's telling me there's green space there, and so they can kind of leverage those two to make the determination. Then TMC, essentially what you see here is, again, this is the center's view. This is TMC. They right-click, they request a time. That time comes across right there, they're requesting. It gets sent across to the center, and then the center approves it.
What prompts the TMC to know to request an earlier time?
Yeah, which is that IDAC green space, red space.
Well,
Yeah, so our system is essentially always under the hood generating these predictions of where we think. And for those controlled flights, you know, we let them kind of, we let them move on the timeline where we think they're really kind of, the demand is manifesting itself. And so that actually provides two kind of alerts to the controllers, not like formal alerts, but if you know your control time's here and the system's starting to tell you this flight we think is going to not be able to take off until up here, all of a sudden they are informed, well, maybe I need to reschedule for a later time, or vice versa. Their control time is here and all of a sudden the surface system starts kind of putting them down here and there's some green space with IDAC, they can start to think about rescheduling. Any other questions? Okay, so in this graph here, so at the 35,000 foot view, what do we see is that by renegotiating these early slots in the overhead stream, that we've saved 357 hours of delay. And that's for a set of roughly 2,700 flights have renegotiated for these earlier times. As we mentioned, you know, whereas surface metering is trying to shift kind of time from the airport movement area to the gate, this renegotiating for the earlier slot is really a reduction in delay. And so this 357 hours can actually be converted to monetized for the airlines in passenger value of time and also flight crew savings. And so all this delay here, this 357 hours, because we got those departures off the surface earlier, the airlines, the operators have less block time that they have to pay for because they're kind of merging into the overhead stream earlier. So this actually not only saves fuel, but unlike many of the other benefits, it actually has this monetization of flight crew time and also passenger value of time. Here on the bottom, we're showing the count of departures that renegotiate for this earlier slot in the overhead stream. What you can see here is there's a big tick up. That's when Atlanta Center came on board with IDAC. So once Atlanta Center came on board, then there's more opportunities to kind of use IDAC to reschedule for these earlier times. When you provide controllers these nice tools, they like to use them. So you see here, boom, this big tick up. So this is the count, and then this is the time saved in hours. And you can see here that we hover between, you know, 20 to 35 hours per month of delay that we're saving by renegotiating those slots in the overhead stream. I think, you know, we're very excited about this. And what's really interesting is, you know, these benefits are all distinct. If an aircraft is subject to surface metering and showed up in this slide, it's not going to show up in this slide. And so these are distinct benefits that the surface system is providing. So if we were to kind of put everything together into one pool, and when I say everything, I mean I showed the slide of our three benefit mechanisms. So gate holding for surface metering, gate holding controlled flights that are negotiated while still at the gate, and then renegotiating for earlier slots in the overhead stream. If I bundled all of this up together and said, okay, what type of benefits are we seeing? What we see is that from the life cycle of the project, we've saved 2.75 million pounds of fuel. Yeah, I mean, that is pretty astounding to me, you know, 2.7 million pounds of fuel. You know, you walk down the street, you tell somebody I saved 2.7 million pounds of fuel, they won't even, it doesn't even make sense. Well, is that this room? I don't even know what it is, but it's a lot. So this 2.7 million pounds of fuel is equivalent to CO2 savings of 63,000 trees. So, you know, I think not only are we kind of having this positive impact here for the operators where we're reducing fuel, but that directly translates into these kind of benefits to the environment, which, you know, I think we're really excited about. This 357 hours of delay saved by renegotiating for earlier slots in the overhead stream Like I said, this is actually one of the few that you can think about trying to monetize, because now those operators really do have less block time. That 357 hours of delay is equivalent to $1.7 million in passenger value of time and pretty close to $500,000 in flight crew costs. Lastly, if we were to just kind of sum up all the hours of gate holding or of reduction of delay that translate into this 2.7 million pounds of fuel, we estimate that we've saved over 2,000 hours of reduced engine runtime on the engines at Charlotte. So overall, I think that this is something that we're very, very encouraged about. And if you think about extrapolating these benefits across the NAS, where with TFDM, it's something you can get kind of pretty excited about pretty quickly. So really interested to see kind of the evolution of this as we expand to new airports with TFDM. Lastly, the title of this talk was, what kind of benefits are we seeing from surface metering while making sure that we're doing no harm to other operational metrics. And so I could show you all these slides that I showed you, the 2.7 million pounds of fuel, the 2,000 hours of engine runtime. But if it was having a negative impact to on-time performance, then none of this would be possible. Because if we start kind of delaying aircraft and we delay them at the gate, which then has a negative impact downstream and they get to their on-time destination delayed, then very quickly you kind of lose all that momentum behind surface metering, because you're having negative impacts there to ultimately the number one, one of the number one metrics for the airlines, which is that on-time performance. So we took, we have a keen eye here on this on-time performance of the destination, and that's what we're looking at here. So in the top graph, on the left-hand side, we have January. On the right-hand side, we have December. So we started surface metering essentially the last day of November in 2017. So if you look back at this blue line, which represents 2017, essentially every month except for this very, very last month, it was non-metered. So 2017 was a non-metered year. Green is 2018, where we metered essentially throughout 2018. However, if you go back and you look, we only metered in banks 2 and banks 3 for the majority of 2018. So what we did is we said, okay, well, let us first kind of track this outbound on-time performance. So A0, for those that are not familiar, is a metric that tells you if you arrived at your destination by the scheduled time. If you are at your destination at or before the scheduled time, then you're compliant with A0. If you're at your destination later than the scheduled time, then you're non-compliant to A0. So the vertical axis here is the compliance to A0, and the blue, again, is 2017, our unmetered data. The green is 2018, our metered data. And in the top graph is essentially all outbound departures from Charlotte to every downstream destination. And the bottom graph here is the same graph, but focused specifically on banks 2 and banks 3. And so why did we do this? And the reason being is kind of captured down here, is because, if we do any type of year-over-year comparison, we're not completely in control of what's going on, right? There can be a lot of outside influences that impact that downstream on-time performance. So we said, okay, well, we're not necessarily in control. So if we just do across all banks a comparison and we say, okay, well, we were 58.8% compliant in 2017. We were 57.5% compliant in 2018. Across all banks, we see that our year-over-year delta was that our downstream A0 compliance declined by 1.3%. And we said, okay, well, What if we focus specifically on those banks that are surface metered, banks 2 and banks 3? And so what we see here is that, again, if we compare 2017 to 2018, the year-over-year change for the metered banks is the same as the year-over-year change for all banks. And what that indicates to us is that we're not necessarily in control of what's kind of dictating or influencing this minus 1.3% year-over-year change across all banks. However, the fact that we're doing just as good in our metered banks indicates to us that metering is doing no harm. And what do I mean by this is that if metering was having a negative impact to the downstream on-time performance, we would expect for these banks 2 and banks 3 to have an even worse year-over-year performance. So if we looked across banks 2 and banks 3 and we saw minus 5% year-over-year performance, that would be an indication that metering is having a negative impact. The fact that these banks that are not metered are showing the same performance as our metered banks at least indicates to us that we're having no negative impact on that downstream on-time performance. So this was the departures out of Charlotte and focusing on their on-time performance. One of the questions we often get is to say, well, metering is great, but the second you start holding all those departures at the gates, you're going to create all these gate conflicts. All of a sudden, all your arrivals aren't going to be able to get to the gate, so you're just going to create a mess in the ramp. So one thing that we said, okay, well, let's look at our on-time performance for the inbound aircraft into Charlotte. The idea being here is that if we were creating unnecessary amounts of gate conflicts, if we're creating kind of complexity and congestion in the ramp that is having a negative impact, then our on-time performance for those arrivals into Charlotte would show some type of degraded performance. What do we see here is that if we again do this year-over-year comparison, across all banks we actually see an improvement in the on-time performance for those arrivals into Charlotte. But that when we actually focus specifically on banks 2 and banks 3 that are metered, we see an improvement, which is that, across all banks, we're seeing a 2.3% positive year-over-year change to that inbound arrival on-time performance. However, specifically in the metered banks, we're actually seeing a 3.3% improvement. What I think we would say is that we're not claiming here that surface metering is having a positive impact to arrival on-time performance for those arrivals inbound to Charlotte. But what we are saying here is that we see no evidence of negative impacts, so that we're doing no harm. I'm not fully convinced that we could stick our stake in the ground and say that we are doing positive, but that this metric is telling us, conversely, that we're doing no negative harm to the system by surface metering. And that is really the bar that we're trying to jump over. We're not trying to improve on-time performance. We're trying to maintain on-time performance while achieving these other benefits of fuel savings, of passenger value of time, of reduction of delay, that type of thing. So with that, I believe that was my last slide, and we have about 10 minutes here for questions. So let me see. Okay, so the first question I see here are results at Charlotte representative of what could be expected at other airports with different gate and or arrival departure runway capacity? I would say that the benefits would be dictated by the arrival demand, by the demand capacity imbalance. So that if you have an airport that has a severe demand capacity imbalance, you should be able to achieve these benefits because you can shift that time from the AMA back to the gate. If you're at an airport that doesn't have any type of severe demand capacity imbalance, then you don't really even have the opportunities for the surface collaborative metering, for the surface metering. However, for negotiating slots in the overhead stream, you can imagine that the demand capacity imbalance on the surface doesn't really dictate what's going on in the overhead stream. So that's where you can imagine, some of these benefits from gate holding of the controlled flights or renegotiating for those earlier slots in the overhead stream. I think those are kind of directly applicable to all these other airports. For the surface metering benefits, I think, the $1 million question there is how bad is the demand capacity imbalance on the surface? And I think that was our only question on the app. So if anybody else has any questions, yes.
One statement, one question. On your last slide, I think it would make more sense to calculate taxi in time.
Mm-hmm.
Delay, was it delay or not, versus A0?
So I would say that our feeling is there's a lot better metrics that would tell us a lot better of a story, but that when we work with the airlines, that this is the metric that essentially drives home kind of the confidence in the system. And so that when we report this on-time performance, it's not necessarily me standing here saying, I think this is the best metrics that gives me the best visibility into what's going on, but that the operators, the airlines, have kind of came to us to say, this is an important metric that we need to kind of raise to the level of importance so we can create a cohesive message to upper management, if that makes sense.
Yeah, I get what you're saying, but that's not really right. I mean, if you're trying to say that we're not, by holding the airplane at the gate, we're not screwing someone else who needs to come to the gate, that's not the right message.
So I mean, I would argue that if we're screwing somebody up, it should show up in the A0 here.
Yeah, but A0 is padded. If all those airplanes landed early,
But as long, I agree it's padded, but it's also padded before and after surface metering.
okay, so that was a statement. My question is, do you have the overall dollar savings? You show a lot of engine run time in pounds of fuel, but do you have the total dollars?
We don't convert to dollars. So you can convert from pounds to gallons to dollars. We are indifferent to that, so we just measure the pounds.
Same thing for engine run time? Do you do anything for dollars for that?
Again, yeah, we are indifferent to that because, the fluctuation of oil prices and stuff like that, we kind of are hands off on that. We think that if you took our estimate of pounds and you're interested, you can convert to dollars.
How do you get the other dollars, like passenger and fuel?
So that's guided by FAA standards. So that, first of all, for passenger value of time, we estimated the average cabin size of a controlled flight. We also estimated the load factor of those controlled flights. And from that, we start to estimate how many passengers are on that. And then we use an FAA standardized metric that says one passenger is worth this many dollars. So for passenger value of time and for flight crew costs, those are coming from like some standard calculations. Those are not as volatile as oil prices, so we feel more comfortable kind of plugging those in. But oil prices today versus 2 weeks could be whatever. Any other questions?
We are still looking for another better idea to measure the benefit from such metering pre-schedule of first flight in our project. So if you have any idea, please let us know and we can develop a new methodology to measure the benefit.
I just want to say, from our side, thank you, because this is the exact kind of data that we need to go to our executives to really get the ball further rolling. Because, stats usually don't lie, right? And these are good statistics. It's something that we can go extrapolate across our network and go back and put a nice big dollar figure in front of our executives. So thank you for all the work you guys done.
Thank you. Yep.
Next other question, how do you define the aircraft, the arrivals in banks 2 and 3? Was it based on schedule or when they arrived at the gate?
Yeah, it's their actual in.
So you could have delayed flights past the gate, past the bank, and that could have driven your increase in compliance.
Yeah, although I would say that we try to pick these kind of, you know, and working with this is actually leveraged directly from ASPM. So we don't have this nice way to cluster the data into our banks and stuff. So our notion of exactly which flight should be in banks 2 and 3 is rather general, and it was defined by 9:30 to 12:30. So that 3-hour period, if you had it out or in during that 3-hour period, then you're counted as metered bank.
Bank 2 is a 3-hour period.
So, each bank is about an hour to an hour and a half. So banks 2 and 3 combined, 9:30 to 12:30.
Okay, so 2 banks within 3 hours.
Yeah, essentially. Any other questions? Yep.
Jeremy, I think in defense of this metric that you have up here, American asked NASA to come up. So I'll give you an example of a pilot that came to my office in Charlotte, and it kind of dawned on him, but he was thinking of the pay portion. And I'm gonna throw numbers out that I'm making up, but this is the example. He says normally I start from the gate at 8 o'clock. I go out and sit in the queue time, and I take off at 8:20. Now you're metering, I'm staying at the gate till 8:10, whatever, and I'm still getting off at 8:20. He was expecting an improvement in getting off the ground, whereas as the metrics show, he's saving money by not being out there in the queue, but these metrics show that there was no harm on the other end. He still got at his destination at the same time or better. So that was, I think that's kind of what you were looking for.
Yep. Exactly. Yep. So, yeah, I mean, we know that in the perfect world, there's a lot of things outside of our influence once aircraft leave Charlotte or, you know, before they even arrive at Charlotte. However, we also know that when you're talking in the business world, you know, me as a data scientist, I can cook up a lot of metrics that I think are great, but if I can't communicate them to management and they don't care about those metrics, then you're kind of painting yourself into a corner. Okay, and then in case anybody wants to kind of ask any additional questions or reach out, I have my email on the slide, so feel free to reach out if you want. If there's, let me check one more time the conference app. Okay, well, if there's no additional questions, then we can call it a day for today. I'd like to thank everybody for joining us.